Okay, so let's start with the first recording. We prepared everything, so we have RoboDK station with a valid robot with a defined, calibrated, measured tool and frame. We have the home position. I just start the VR application, Steam VR, and I just switch on the tracker. You can see from the status LED that the connection is built up, and you can check this on the screen as well. Okay, that seems to be fine right now. Anyhow, if some of the components is missing, so if you don't have any RoboDK file open, if you are missing one of the must-have components, robots, either tool, either frame, or the VR connection is not built up, not active, then you will get a failure message during the starting procedure of the Easy Automator app. But right now we have everything right, so we will just start the application. And once it's open, I just hit start recording. So everything's fine. The pen, we will use the pen as a manual tool. Seems to be everything fine. Tool and frame, it's okay. And then start recording. So I just have to follow the instructions on the screen. That means just hitting 0, X, Y. As you can see, I already have the robot on the screen moving and following my hand. I just have to come back to the 0 point to check out the accuracy. So we are below 1 millimeter, 0.89 millimeters. This is fair enough. First, I will just record a starting point. Let me say here. Then I'm coming to the origin start point. With 1 point, I recorded the start point, and I'm recording the end point with 1 additional point. Okay. Then I come back to here, not moving directly over the surface of my workpiece. Then I'm coming back to the origin and recording the second axis. I'm coming back to here again. And now I will record this part with a continuous recording. And you will see that we will be able to record even the speed, depending on the change of the speed of my hand movements. We will record new speed values as well. Here I'm moving slowly, then quick again. Okay, I just released the button, so the continuous recording is not running at the moment. And I'm just coming back to here to this position, and I'm recording 1 additional point. So this should be fair enough. The recording does not run anymore. I just wanted to visualize the pan, which you can do. You can see on the screen, if the robot can't reach the pan anymore, you still see the pan, how it is moving around in my hands. And once we are coming back to a region where the robot can reach this again, then it's ready to go. If you have this problem that the robot is choosing a different kind of configuration than you want to have, then you can always double hit the home position. I try to reproduce somehow. Okay, maybe right now this will, no, this is too good. Anyhow, if you hit the home position, this will come back to the home position again, and then you are ready to go again. Okay? So, okay, so the recording is finished. I'm just checking out with double-clicking the program if we can reach all of the points. It seems to be so. If you want to change the speed of the simulation, you can do this here, and then really you will be able to see that this is running very fast right now, and you can speed this up. Additionally, with the plus minus signs, you can increase the size of the coordinate systems, which are representing the tools here, and the frame, of course. We have everything, so it seems to be there. The next what I would like to do right now is I'm just going to the first, the P1 here with the robot. Bam. And I am just hitting the move joints. Before I do this, I reduce the speed, and for sure I have to switch to remote, and if I hit move joints, then you can see that the robot is very slowly moving. Why I'm doing this so smooth and so slow? Actually, this is the first time after the creation of this program that I'm moving the robot, so I'm quite confident that we have done everything correct and right, but still I want to check out with a slow movement that I don't crash anything, I don't hurt anybody, and that this is safe to operate on a manner. You can see that the flange is rotating around because at the home position I was not taking care about in which position, which orientation this tool was recording. Anyhow, you will see right now we will reach the position of the first point. Then I will a little bit raise. I will raise back the speed that we can move on. I will check out this origin position and this position of the x-axis, if we can reach it and if it's everything fine. So this will be 1. Okay, then move joints. Still very slow. I'm just speeding it up. So with the on the teach panel, please don't get irritated. I'm just getting this connection status unexpected error. I had some problems with my RoboDK installation during the development. Maybe I just destroyed something or overwritten some values, but this does not influence our procedure at the moment. You can see we have approximately an overall tolerance, I would say up to 3 millimeters with this system. This is a summary of the frame of the tool definitions, which we have done earlier, the actual position, the actual performance of the optical system, and for sure the manual movements as I was recording all the points. I'm just coming back to the first position. I would do so if I would not be in remote mode. And I'm just coming to the third position as well, just to check out if it's good enough. Yes, this should be good enough for our purposes. So I'm just coming to the first position, or I could even move to the home position. Here, the move joints. And I just renamed the program. So I will not apply any kind of offset. There are a couple of ways how you can do the offsetting. I will show this later on. I just renamed this program right now as the date by today 01. And right click and just check out if the right post processor is selected. In my particular case, this is Allied CS task. This is the way, or this is the post processor which I prefer. This is depending always on your robot what you are using, and then just simply hit generate robot program. Right click and generate robot program. This will be created. Okay. I just make one failure at the moment, I think. Documents, RoboDK, programs. I just clean up all these because I created one program, and I just generate robot program again, and then you will see that this fresh new file is created here inside. So you can check all the lines in the program if you want. And I'm just opening up FileZilla. You can do this directly from RoboDK as well. Sorry, this was not a good idea. This one, if you hit the Explore button, I already configured my FTP connection to this robot. Therefore, all of the previous programs I will just simply delete. For the FTP connection, please contact or look in the manual of your robot manufacturer. So I am in the right folder. On the right side, I'm on the robot. This is the robot controller. This is my PC where the RoboDK programs are stored. So I just double click it, and this will be automatically copied to the robot controller. And if you are coming to the local mode and I'm coming to open task, you will see RPRPIG. So exactly this which we just created. Excellent. Seems to be very fine. And if you are coming to the task menu, then you can see all of the waypoints. At the very beginning, you can see this with the 200 millimeters per second. And here you can see the reduced one. Please don't get irritated. We have a quite big value for the smooth value. The smooth value is defining, there's a kind of rounding between the points, which is somehow here a little bit senseless because we are creating at each millimeter 1 point with this setup, and we want to make a smoothing of 15 millimeters between the points. The robot movement will be very smooth, but we lose some accuracy. Nevertheless, just test this out. I just reduce the speed. The first position should be navigated there manually, I guess because of safety reasons. So we can see that we don't crash anything. And once the first point was reached, then we can switch to the automatic mode, and the robot will move around by itself. And you can see we even have a small offset on the Z-axis, which not so bad at the moment. And you will see as well that even the speed of the recording, so I don't touch anything, even the speed of the recording will be automatically transferred to the robot. How to make it with the offsetting? So just for your reference, I will show you, I will change the smooth value to 1, that you can see the difference. I just rename it to 02 in the end, and I just generate again the robot program, which was done with just some mouse clicks. I can close this, refresh. The second program is here, double click, and we just copy this to the robot controller. I'm just coming back to the open task, and here you can see that even the freshly copied new file is already selected. So I just open it. And you will see the difference. So at this point, nothing, because we just recorded the start and the end points. But with the other points, you will see that the robot is, it's just all the time accelerating and stopping between the point. This is for some processes are not really useful, and therefore we can compensate this with the smoothness value. But there are a couple of ways how we can fix this, and I will show you open up. However, I think in not even 15 minutes, we recorded a path, we checked the path, if it's approximately right, and we transferred it to the robot, and we just tested this out. So this is quite an easy and fast process. So we will move to the next section that I will show you how you can do the same recording, not in front of the robot, but for example, in front of me, because this is then easier to do.